These are the 2.5 notes for pre-calculus. Essential question for today, how do I graph transformations of functions? So we learned a little bit on Delta Math about how these transformations work. So this is just our official note page on them. So you have vertical shifts, which means the graph will either move up or down. If you see a plus, it means up. If you see down, for the negative. So these three examples here are examples of things that are either going to move up or down. So this plus 5 right here is going to mean up 5. The minus 3 means down 3. And the plus 10 means up 10. And if you notice, each of these is a slightly different graph. This first one, x squared, is a parabola. The second one is a V shape, an absolute value graph. And then this third one is just an f of x graph. So they don't tell us exactly what that is, but we know that whatever the original graph is, it's going to move up 10. All right, for the second part, you've got your horizontal shifts, your right-left movements. So if it moves to the left, you will see a positive sign. And if it moves to the right, you will see a negative sign. So that's actually the opposite of what you would think, opposite sign of what it looks like. So this first one, since it's plus 2, it's actually going to mean left 2. Here, it would move right 3. And this last one, again, right 9. So just a quick difference between the vertical shifts and the horizontal shifts. These vertical shifts are kind of at the end of the problem. Notice. And then these horizontal shifts I like to describe as being inside. So it's inside the parentheses, inside the square root bar, inside the parentheses. So either at the end or inside. The next thing we have are your flips and reflections. That's if you see a negative sign. And then you're going to have if you see a negative in front, it's going to flip it up, down. If you see a negative sign inside, it's going to flip the graph from right to left. All right, so here I see a negative out front. So that's going to be flip, up, down. Versus here, the negative is on the inside of the parentheses. So that's going to flip to the right or to the left. And then here I see it out in front again. So that's going to flip it up, down. The last transformation we're going to work with are stretches and compressions. Stretch is when you make it taller. Compress is when you make it shorter. So that's always going to be represented by the number in front. Here I see a 3, which means this is going to be 3 times as tall as normal. So think tall and skinny. It's going to stretch the graph. The second one is a 1/2. So think about it as being 1/2 times as tall. Half as tall means it's going to be shorter. So it's going to be a compression. So think it's going to be shorter. Stretch is going to be taller. All right, on this last one, we have our f of x function. We have a 5 in front. So this is going to be 5 times as tall. So it's going to be a stretch. So it means it's going to be taller. And when something's taller, it's skinnier as well. All right. So down here on problems 1 through 8, it just says for each function, describe the transformation or transformations. Now, for some of these, they tell us exactly what type of graph it is. Other ones, they just give us the f of x. That's not really what we're concerned about. We're just trying to decide what the transformation is. So here I see a -1 on the inside of a cube root. That means it's going to be a horizontal shift, and negative actually means I need to move it to the right 1 place. Problem 2, I see a negative sign, and it's on the inside. So that is going to flip it right, left. Problem 3, I see a 2 in front of it. Any number in front is going to be a stretch or a compression. So this is going to be 2 times as tall. So that would be a stretch. It would be taller. Problem number 4, you have a lot going on. First, you have this negative in front of the 5. So that's going to flip it up, down, since it's out in front. You've got the 5, which is going to make it 5 times as tall. Then you've got the plus 8 at the end, which is going to move it up 8. So take a little bit of time, see if you can fill in the transformations for 5 through 8. All right, so check your work on 5 through 8. Noticing that on problems 5, 7, and 8, you just have the f of x function. But on number 6, they specifically tell you that it's an x squared graph, so I know that number 6 looks like a parabola. I'm not sure what 5, 7, or 8 looks like. So anytime you have an f of x, you're unsure of the shape. But when you have an x squared, or up here on problem number 2, you have an x to the third, it kind of looks like that. Problem number 1, you've got this shape. But anytime it gives you an f of x, they're not telling you what the shape looks like. Okay, on the back side, we're going to take some graphs and we're going to shift them around. So it says describe the transformation, and then we're going to go ahead and graph it. So on problem number 9, the graph of y equals x squared is shown. So they're telling us that this parabola right here represents the graph x squared. And then they want you to graph y equals x squared minus 4. The only thing that's different is the minus 4. And I know that if I have a number at the end, it's going to move up or down. So this graph is going to move down 4. Now, when you take a graph and move it down 4, you have to identify several points and then move those points. So this first point I'm going to pick is right here at the center, 0, 0, and I'm just going to move it down 4. Then the next thing I notice is right here, it crosses at 1, 1, and I'm going to move that point down 4. Crosses again exactly right here at 2, 4. I'm going to move that down 4 places. And the next place I notice is right there, 3, 9. And I'll move that down 4 places. So that's half of it. I'm just going to do the same thing on the other side. You can do as many or as few of these points as you like, as long as you get the same shape when you're done. All right, example number 10. This one just says the graph of f of x is shown. So they're not telling us exactly what this graph is. They're just kind of graphing something. And they want us to graph f of x plus 7. So f of x plus 7, notice the 7 is on the inside. So it's going to move right or left. And it's a plus. So it'll move the opposite direction of left 7. Again, we're going to identify several points on our graph and then move those points left 7. So I'm just going to make sure I get all the ones that are going to give me the basic shape. I'm going to do that point right there. Maybe this point right here. I know there are several more that I could use, but I don't want to spend all day doing this. So I'm just going to get some of the main ones. I feel like if I graph those 5 points and scoot them over to the left 7, I'll have a pretty good idea of that shape. And then one by one, you just move them over. You just fill in the line. So it looks exactly like the same shape that you made. The only difference should be that the graph should be scooted over left 7. All right, on the next one, it's problem number 11. He says the graph of y equals the square root of x is shown, and they want us to graph y equals negative square root of x minus 5. So let's think about what's happening on this graph, what the transformations are. I've got a negative in front, which means I'm going to flip this right top to bottom, up, down, top to bottom. I also have this minus 5 here. So you have to think, is that at the end or is that inside the square root bar? That's definitely at the end of the problem. So it's going to move it down 5. Different than if it had x minus 5 like that inside the parenthesis, inside the square root bar. All right, so now we're just going to identify a few points on this graph, and then we're going to move them down 5 and then flip it over. 1. All right, so I think those 4 points will work pretty well. And I'm just choosing the ones that are exactly whole numbers, that are crossing exactly on my grid lines. You could do these two in any order. You could either flip it or move it down 5 first. I find it easier for me if I flip it first. So when I flip it, you're just moving anything that's above to below the line. So this dot here is going to stay the same. This one right here is going to flip down. This one is 2 above the axis. I'm going to flip it 2 below the axis. That's 3 above the axis. I'm going to flip 3 below the axis. So I kind of get those points there. So that's kind of where my first graph is going to be. Then I'm going to have to move that down 5. So each point down 5. And there's my final graph. So I'll just fill that in. Notice how it's kind of upside down compared to the original red graph. All right, the last type of problem we are going to do is we're going to try to identify and write the function. Problem number 12 says the graph of y equals absolute value of x is the solid black graph below. And they want us to write the function that represents the dotted graph. So we're going to try to figure out how the black graph is related to that dashed red line. So to me, it looks like the graph got moved over to the right. Got moved over right 4 places. So that would have shifted the black graph over 4 places. And then it looks like it got flipped upside down. So flipped top to bottom. We need to make sure we're writing it into this function here. So if I needed to move it to the right 4, I would want to write that on the inside of my absolute value bars. And it would want to look like the opposite sign, which would be a minus 4. So I'm going to write it as y equals absolute value of x minus 4. Notice I left a little room in front because when I flip it up, down, that means I have a negative sign in front. So I'm going to save room to put a negative sign right there. And there's my equation. All right, let's take a look at the next one. Notice the next one doesn't tell you what the function is. It just says it's f of x. So we just have to figure out how the black graph will get moved to make that red dotted graph. So for me, I think it's easiest to identify a point. I like to kind of use the vertex right here and figure out, okay, how did it get over to there? It looked like it moved up 3 and left 3. Now, I do notice that these parabolas are upside down, but the black graph was upside down originally, so it didn't get switched over. You're just making comparison of the original black graph to the red dashed graph. All right, now using the f of x, we are going to write it as f of x, f of, and then we're going to move up 3 and left 3. So the left is what's going to go inside the parentheses as a plus 3. Remember, always the opposite. And the up 3 is going to go at the end. So f of x was my original graph, and I moved it left 3 and up 3. All right, same thing on the last one, number 14. Notice it's just giving you f of x. So let's just identify what's happening. The black is your original graph, so I'm just going to put a dot maybe right there. That looks like a good place for me to figure it out. And it looks like that same point is right there. Just kind of shift it over. So you're just trying to figure out how far you went from the black graph over to the red dashed graph. Looks like to me it's left 5 and down 2. Left 5 and down 2. All right, so I'm going to put my f function here. The left is going to have to be represented inside, and the down will be at the end. So left 5, opposite sign of what it looks like, down 2, minus 2. All right, there you go. If you have questions, let me know.